And he's going to tell us about methylation-based clock at the organ level. Thank you, Gavin.
Thank you. Okay. Yeah, thanks for the organizer. And my name is Gavin Zhou, and it's been great to be presenting at this venue because I actually did my PhD just upstairs. So it feels great to come back and see all the folks and all the church lab members in the audience and seeing the entire Longwood community. And it feels great to also be the sponsor representing our company, Regenerative Bio, for this great conference. As it's not just giving back to the research community or just simply paying back the free food I had during my PhD, but it's all about still keeping this place as an exciting platform and venue for great science, like great minds and all the wisdom here, and especially bringing new talents to the aging field. So I'll start with a little bit background. So we are working mostly thinking from using or applying the biomarkers of aging in multiple different kind of scenarios, including prediction, prognosis, or monitoring the interventions during the entire kind of anti-aging or pursuing anti-aging process, and also discovering all these new solutions, including new drugs or other interventions on, say, lifestyles, or even the combinations of multiple interventions. So I just quoted a few figures from the trilogy of all this great work from the consortium of biomarkers of aging. So if anyone in the audience have not read all this characterization, validation, and translation of all these biomarkers of aging, please do. This is your homework. So at Regenerative Bio, we're just thinking to building a more kind of a closed loop from the research to translational, the longevity science, into more kind of practice and solution. So by doing this, I think I don't have too much time today to cover the science, but basically from yesterday, it will be our pleasure and also our honor to already hear, or I think half of our SAB members talking about the science. And so I just simply save some of the time on the aging mechanisms or the assessments or the others, how this leads into effective intervention. So we are more leaning towards to using the kind of a globalized resources we can leverage on by building different research centers in terms of the talents, and also leveraging some of the unique kind of a population or their cumulative kind of data or efforts on clinical centers. Since we already have, say, the Life Longevity and Wellbeing Center in Japan, and we are starting our new clinical centers in UAE. And with together our, say, the research efforts in here, Boston, and also in China. So there's two core platforms for Regenerative Bio. One is our organ aging clock, and I will explain this later in details. And the other is more from anti-aging kind of a substance screening. So it's more like different kind of biology applying through this kind of AI-driven drug discovery or substance screening kind of a platform. And we are very lucky or have all the talents from not only the science side, but also from the business developments and all the management side, and later commercialize and translate this into three different kind of operational models or our core brandings, which is HCR for aging detection, and also our anti-aging intervention. Our core brand is Life, and we also have a slightly different flavors of Growland. We have a few colleagues outside introducing more about Life, so feel free to stop by at the booth. And the core technology on the organ level kind of aging clock is leveraging all the knowledge I think talking about yesterday and also today on the DNA methylation for characterizing the aging kind of a process. And we are thinking this more deeply and leveraging the wisdoms from, say, cancer genomics and also cancer early detection, which is what I did starting from my career in bioinformatics and genomics, and also efforts on identifying the more kind of tissue level or the tissue for origin of certain, say, the biomarkers, and combining this with the assessments on biological aging. And we are adding more of the information level in terms of the fragmentomics and also the other part of the DNA, which is the genetic factors, into this combination model. And this is just a quick view because some of our core pattern is still proprietary. So we've been using some of the other models learned from, say, weather forecasting or a slightly different kind of AI model to give you a sense that we're not only using all this DNA methylation as a marker of aging, but also these markers on the cell-free DNA also tells us where they come from and what the status of a certain organ. So this will lead us to the aging clock. And we also standing on the shoulders of the giants of BioLearn. I think this paper is still on bioRxiv, but I think it's already a very like revolutionized milestone in the field. And we luckily comparing the existing model with our own more clock and showing not only the precision, but also the power of using our own clock at aging level without losing any accuracy for predicting the biological age. And the other part I want to digress a little bit on the intervention side, because we are also working on applying this traditional kind of AI models into discovering, say, different substance or ingredients. So this is just a high-level kind of overview to combining multiple different models like the diffusion model, prediction, and also a little bit on the GPT or large language models into multiple views, and later providing this kind of anti-aging score for the substance screening. And this will give us the RevOrgan for our kind of substance screening, and we have comparing this in 3 different sets with all the existing deep learning models and showing a very precise kind of in terms of the prediction, and they're just simply by comparing the AUC. And furthermore, to building this kind of a closed loop, we are using all kinds of data we can get from the wet lab, like the cellular level and also the organelle levels, and to later validate whether the predictions coming from our, say, the algorithms or the models actually have their expected kind of anti-aging efficacy or so-called the effectiveness. So this gives us a lot of learnings, and this learnings can later providing this kind of a feedback loop to the entire training model. And we have luckily to generate multiple like different solutions for certain health needs. This is just a quick example, and we are also using this furthermore to working on the cohorts to follow up whether this have the efficacy we expected on certain health needs, and through a more kind of oral supplements check, but also this is following by a more well-designed clinical trials. And beyond that, we are also trying the different kind of solutions for anti-aging kind of solutions in a more offline setting by building our own longevity clinics. And this is hopefully give you a overview on the entire kind of translation biomarker of agents into this closing loop by understanding the assessments and convert that into the design and screening, and later on to provide this as a total solution for the kind of complete anti-aging solution. So with that, I just want to highlight our vision and mission. We hope to provide a graceful aging for everyone. So thank you.
Thank you. Thank you so much. Gavin will give 50% discount to the first 20 people who will sign up. Let's spice it up a bit. Okay.